Does anybody remember rationalizing denominators before, Ryan? Do you remember where you did do it? In a previous class. Does any? Yeah, in geometry, when you did the special right triangles, you probably had to rationalize denominators. Just to remind you, in geometry, we had formulas for the side lengths of two special right triangles, and one of them was 30, 60, 90. The other was 45, 45, 90. Just to use one of them as an example, I'll say this is a 45, 45, 90. Right? And we knew the formulas for the length of the sides were that the two legs of the triangle were equal. You can call it x, you can call it n. Some books say n. But whatever these are, this was x times the square root of 2. So if, for example, I said, here's a 45, 45, 90, and I know that the hypotenuse is length 5. Find the length of the other two sides. I would have compared it to this and said that 5 is equal to x times the square root of 2. And then I would have solved for x by dividing by the square root of 2. And if you did that, then you got this. But you weren't allowed to keep that irrational number, an unresolved radical, in the denominator. You had to take a step to get rid of it, and that was called rationalizing the denominator. Right. So notice the pattern here, right? When I rationalize the denominator, I multiply by the denominator divided by itself. Because what is anything divided by itself? It's 1. So essentially what we're doing here is multiplying times 1. And that doesn't change the value of anything. But it will change the form. Right? The square root of 2 times the square root of 2 is 2. And 5 times the square root of 2 is in the numerator. So that's the process of rationalizing a denominator.